for section 22, chapter 22, section 2. We're going to talk about how electrical energy gets used, something very important in all our lives. Electrical energy can be transformed into other kinds of energy: radiant energy, lights; thermal energy, like heaters; and mechanical energy, say an electric motor. I also want you to pay particular attention to this unit. Kilowatt hours is what PG&E charges for energy in our homes. So fundamentally, when charges move through a wire, moving charges is current. When they pass through a resistor, the resistor takes the energy from the current, the voltage. Where does it go? Well, basically, it increases the thermal energy. It makes the resistor get hot, which means all the little electrons and atoms inside the resistor bumping into each other. And if you remember from chemistry, temperature is a measure of the average kinetic energy of the molecules bumping into each other. So current makes resistors hot. Now, we've run into power once before in the last unit. Power equals current times voltage, right here. Now all we're going to do is add Ohm's law in, and you can rewrite Ohm's law in different forms. For example, we could replace delta V with IR. So we'd have I times IR times R, or I squared R. Similarly, we could replace the I. Ohm's law says that I is delta V over R. So we could form this other delta V squared over R. These two equations plus power equals delta V times I are all the same. They're just combinations when you bring Ohm's law in. Why are they useful? Well, sometimes you know that the current in the problem, but you don't know the voltage. So this equation could be useful. Or here you know the voltage, but you don't know the current. So this equation can be useful. You don't have to, because if you knew the resistance and the voltage, you could find the current. Or you knew the current and the resistance, you could find the voltage. So you can always fall back to just using these two equations instead of these combinations. So let's consider a real important case of how energy gets moved around. As you probably know, energy is generated in power plants, and they get moved to us on big, what's called high tension wires or high voltage wires. Wonder why they bother using high voltage, because then when it gets to our homes, they have to lower the voltage before we can use it. And the answer is because it's the current in the lines, the moving charges bumping in to things, that creates the heat or the lost energy. So what you do in a transmission line is you increase the voltage and reduce the current. That's why they run the high tension wires at hundreds of thousands of volts and reduce the current so that the amount of heat generated inside our wires is I squared R, and by reducing the current, we reduce the heating, so more of our energy gets delivered to our homes. And here they just kind of go through a little example with you as you read on how much energy gets lost, and they point out that long distance lines, our house has 120 volts, long distance lines can have up to 500,000 volts. Okay, now we're going to do some problems where you're going to calculate how much it costs to run different appliances in your home, for example. And what you need to realize is that what we call a power company like PG&E isn't really a power company. It's an energy company, because what they sell us is not watts. They sell us essentially joules of energy. Think about it this way: your parents don't not only care how many lights you leave on, that's more watts, but they also care how long you leave them on for, because it costs more money if you leave them on. So the unit that we're going to use, you could think of it as like, well, it's energy, which is joules per second is watts, times seconds is joules. Well, that's energy. But the power company doesn't sell it that way. They use different units. First off, joule isn't very much. We'd need a lot of them. So they increase the unit for power from watts to kilowatts. So it's how many thousands of watts times how many hours you leave them on for. So when we calculate cost from PG&E, we're going to figure out how much power a device uses, not in watts, but divide by 1,000 to make kilowatts, and then multiply by how long it's on for, not in seconds, but in hours, because these produce more convenient units for us.